I'm going to do exercise 8, both parts, both A and B, for section 1.3 of Stewart's Calculus, 7th edition, early Transcendentals. And I have the question up here, and it says, part A says, how is the graph of y is equal to 2 sine x related to the graph of y is equal to sine x? Use your answer and figure 6 to sketch the graph of y is equal to 2 sine x. Well, if you don't have the book, figure 6 is just the graph of sine x, and I'm just going to graph it here for you. So we have that it crosses the origin up on pi over 2, down to pi, low there, and etc. So it this is sine of x, okay, and its range is from -1 to 1, and that is important in this problem. You'll see why later. Actually, you'll see why right now. So when we multiply, this is the base function in this case is sine x. And what we're doing, the transformation we're doing, is multiplying the entire function, the base function, by 2. And that is a vertical stretch by a factor of 2. And that means we're going to stretch the range of the function. We're gonna take it from 1 and we're gonna multiply it by 2. So now the new range is from 2 to -2. And this is what the new function, the new graph of, oh, that's really bad. The new graph of 2 sine x looks like. Height there, still crosses pi at 0, turning point, pi, etc. You get the point. Okay, and then, so this is the graph of 2 sine x, and then the second part of part A says, the first part says, how is it related to the graph of y is equal to sine x? And all we did, if you'll notice, all we did was change the height. We did not change the intercepts. So one thing you could say is that they're related in that one is simply a vertical transformation, okay? And they're the same in that they have the same x-intercepts, right? And the same y-intercepts, intercept, because they both cross the origin. So it's both functions are still oscillating to infinity and to positive infinity, and they both cross the x-axis at the same places. So that was a pretty easy one. Let's move on to part B. How is the graph of y is equal to 1 plus root x, square root x, related to the graph of y is equal to square root x? Use your answer in figure 4, part A, to sketch the graph of y is equal to 1 plus root x. How is the graph of 1 plus root x related to the graph of y is equal to root x? So that's not too hard. We know, oops, wrong direction. We know that the graph, okay, of square root x looks like something like that. Alright. Now we're adding 1 to that, so that means we're going to move the whole function up by 1, and at 1, this graph is at 1. So 1, 1 here. Alright, and since we're moving it up 1, the new coordinate for f of x will now be at 2. And it'll start here, right? So, more or less. Alright, so the relationship is just that this is y is equal to square root x plus 1, or 1 plus square root x, and they are equivalent. Okay, so the only difference between purple graph here and green graph is that purple graph is just translated upwards by 1 unit, 1 value, and that's really their only relationship. They both are defined on the same domain, okay, from 0 to positive infinity, and that's basically it. And as they go to infinity, they increase to infinity. So this was exercise 8, both parts A and B. Not too hard.